Okay, we're going to continue with looking at our level of significance alpha. Alpha is what determines whether we're going to reject or fail to reject our null hypothesis. We compare alpha to our p-value. So if we say, let's look here, if alpha is less than or equal, if the p-value is less than or equal to alpha, we reject the null hypothesis and we say that our data are statistically significant. Statistically significant enough that we're going to reject our null hypothesis. Otherwise, if our p-value is greater than alpha, we do not reject the null hypothesis. So remember we said that alpha and is, 1 minus alpha is the confidence level. So let's say we're looking at a two-tailed test. And our mean is here in the middle. And alpha is the probability that we are here in those two tails, or in one of them, I should say. And our confidence level is we are within this window of the mean. So this is negative, the absolute value of zx bar, and this is the positive, the absolute value of zx bar. So our confidence levels from chapter 8 said that we were within a certain distance from the mean. And alpha is we are further from that. We are on the outside. So for example, our empirical rule says that if we are at mean mu, let's say 1, 2, and here we are 2 standard deviations below, and here we are 2 standard deviations above. The empirical rule tells that this is 95% of our data is contained here. So this is, if this were a normal distribution that's standard, this would be 0 to -2. So outside of that, if we are beyond 2 standard deviations, if we are to the left of -2 or to the right of +2, that is the remaining 5%. So in this case, alpha equals 5%, or 0.05. So if 95%, if this is 95%, then the part that is shaded in blue is together 5%. Half of it on the left, half of it on the right. So 2.5% on the left and 2.5% on the right. So when we land in this shaded area that is very, very rare, we think that it's so rare that it didn't happen, it's so unlikely that it must be that our mean is not actually where we think it is. So if you are in a situation where your p-value is less than alpha, it means you are further, even further away from the mean. So much so that you think that you should actually, that is not actually the correct mean. So you do reject. So let's look at a little overview now of how we look at these, how we actually do these computations. So in hypothesis testing, we have a null hypothesis H0 or H0, where we claim a particular value for the mean. For example, the mean is k. For our alternate hypothesis, we have 3 options: that the mean is less than k, or it's greater than k, or it's just not equal to k. So this is a claim about the population mean. What we're going to do is we're going to look at a sample. So from that sample of size n, we get the sample's mean, the sample mean x bar. We're going to compare that to the claimed value for the mean. So the claim was that the mean was k. We're going to compare it to our sample mean. Let's go for example, saying that the alternate hypothesis said that the mean is actually less than k. So that carries down to this calculation here. So we're looking for the probability that our sample mean x bar is less than k. So we change that to that is the same as the probability that z is less than our test statistic. How do we find our test statistic? The same way we did for any sampling distribution. It's x bar minus mu divided by the standard error, sigma divided by radical n. That is the p-value. Okay? That p-value is now compared with the level of significance. If it is less than or equal to alpha, we reject our null hypothesis. If our p-value is greater than alpha, we fail to reject the null hypothesis. This process is very similar. It's this, if we had an alternate hypothesis that claimed that the mean was larger, then we would switch our inequalities. And we would find our probability as we have for several sections. One thing we should look at is if your hypothesis down here, this green dot, if your alternate hypothesis claims that the mean is just different from k, then you are in a two-tail situation. If you're in a two-tail situation, you're going to find the probability of one tail and then double it. So in this case, I'm assuming that your x bar is less than k. Okay? If your x bar was greater than k, you would use the other one. So let's put a little asterisk here, and we'll say this equals the probability that z is less than the negative of zx bar. You find your z value and you make it negative. And of course, this is a two-tail test, so we have to make sure we are counting both of the tails. So multiply that probability by 2. After you find the probability multiplied by 2, that will be your p-value. So in fact, I'm just assuming here that your x bar is less than k. Otherwise, it would be a different, if it weren't, then you would use the greater than. I'm suggesting that you use the negative here because it's easier to use our z-table. Our z-table is already set up to tell you values less than to the left of the given z-value. Okay, so there are 4 steps. You have to determine your null hypothesis. You have to determine your alternate hypothesis. You have to set up your probability correctly, as here. You have to find your test statistic and find the probability. Once you have your p-value, you then decide whether you're going to reject or fail to reject your null hypothesis. Take your time. This is a big section introducing a big new idea, lots of terminology. There's another example from the Khan Academy, and if you'd like, I can link to more worked out examples if that's useful. We will look at an example in class together, but please make sure that you're prepped and also take a time to look at the concept check because there's a lot going on in this one section. Okay, thanks. Have a good weekend.